Welcome and thanks for joining us. My guest today is David Kubicki, the Senior Solutions Architect Manager for Palo Alto Networks. David, great to have you in.
Great to be here, thanks.
Absolutely, and obviously we're talking DoD's use of the cloud and specifically how to secure that. What does the landscape look like for security tools within DoD's use of the cloud today?
Yeah, I think it's pretty fragmented. I think that there's a lot of mistakes from the past of what was done with security tools for enterprises. And what I mean by that is a lot of point tools that do very specific things that, and those different point tools can lead to, issues with security and having policy, disjointed between those point products. In addition, the intellectual debt that you have, of trying to staff and manage all of these point tools makes it extremely difficult to be able to get good security. And so what we think is a better idea, or what I think the majority of the industry probably agrees with me on is a better idea, is platformization. So having a platform that provides that consistent security across multiple application life cycles.
Interesting. And so there's obviously cloud native security tools and there's third-party tools that come into play.
Sure.
As DoD moves further into the cloud, how do they strike the right balance there, do you think?
Yeah, I think that's an interesting question. I think the sweet spot for CSP and native tools is probably agencies and branches of the military that are in a single cloud. I would argue that that's not many. And having to build policy across three disparate clouds and the visibility in three disparate clouds can be difficult. And that's where a platform like Prisma Cloud with Palo Alto Networks can bring to you and provide capability across all phases of the application lifecycle, whether it's in development and deploy and run phases as well.
So you mentioned earlier there are point tools. You mentioned there might be some gaps between them. How do they work together today?
Yeah, so it's a great question. Most of them don't. Or there is some correlation that happens at a security tool like a SIEM or a SOAR platform like doing security orchestration and automation. So that does provide some help, and it does provide some additional visibility. But the policy is not consistent across those solutions. So you would have to develop policy for each one of those point tools, and they can become disjointed, and then the manual intervention of having to do that makes it very difficult. So, developing or implementing your security as policy as a code, meaning things like IAC templates, infrastructure as code templates that are known good configurations, providing that security capability within the development pipelines, whether it's CI/CD or if you're still doing some waterfall methodology and things like that, provides that capability, because it's just going to be a whack-a-mole situation with misconfigurations, vulnerabilities, et cetera.
Explain a little bit more about what infrastructure as code means, how that works on a basic level.
Think about it as a recipe for a cake. So it has all the instructions to deploy a set infrastructure into a public cloud. There's a couple of prevalent formats for that. Terraform is one. That's by Hashi. There's CloudFormation, and each of the individual clouds have specific kind of IAC capability. But it's all relatively the same. It basically just runs down and how things should be configured, in every aspect of it, whether it's users, networking access, applications that get deployed, operating systems, et cetera.
Interesting. You mentioned it kind of directs how things should be configured. How is that enforced? Because that's such a big issue, enforcing your actual policy, right?
Yeah. And so that's that idea of shifting left, right? So, one of the capabilities that Prisma Cloud brings is, for simply put, kind of like a spell check for IAC templates. So it'll scan the IAC templates, make sure that the code that you're deploying on them isn't, a package that has known vulnerabilities or critical vulnerabilities or whatever our security risk that we'd be willing to accept. It also makes sure that things are configured according to best practices or, particular compliance standards, obviously very important in the federal space. And it'll make sure that it is adhering to that policy. Of course, as things change and things like that, it'll continuously scan those, make sure, and provide that feedback to the developer that deployed it, or that developed it, I should say, so that he or she can make those necessary changes to the IAC template and get it back to a better state.
Interesting. So essentially, as the software developer is developing whatever kind of widget that DoD or another organization might need, they're getting feedback as they go through that process to make sure the security parameters are being met?
Yeah,
Actually?
I mean, in the ideal situation, absolutely. Not all organizations are quite there yet to providing that, but we feel that that shifting left capability and providing that security within the development cycles is really the only way that you can keep up with the application velocity within the cloud. So hopefully, applications, workloads, et cetera, that you're deploying to the cloud have already started at a known good state, because we do see that developers now have been outnumbering security personnel roughly 30 to 1. I had one agency tell me it was 50 to 1, which I thought was surprising. But there's a lot of alert fatigue. There's a lot of just general fatigue for the security teams in trying to keep up with that application velocity that I mentioned as well. So providing that security and that feedback back to the developers allows, obviously the alerts to be reduced from that, from those applications and workloads, but it also enables the communication between the development teams, the ops teams, the security teams, and reduces hopefully some of the friction that can be the number one cause of development slowdown and decreasing the application velocity is interjecting security.
Okay, and speaking of friction, obviously how two pieces of software connect is through the application programming interface or the API. API security is increasingly a big deal.
Absolutely.
How do you recommend DoD organizations specifically for this conversation go after that?
Yeah, I think the way I think about it is get close to the compute as you can. And the reason why that's important within the cloud is having a appliance, whether it's physical or virtual, is difficult to maintain the routing with the ephemeral nature of some of these cloud workloads, especially containers, right? So the closer you can get to the compute via an agent, we call it a defender, and provide capability of looking at layer 7 traffic or also the ability of importing something like a Swagger definition file for an API for an application is basically a list of all the capabilities that this application has for the API, and then being able to restrict or allow access to those different types of capabilities that the API presents.
Okay, and we've talked a lot about this, but anything else that you think is important to mention around how organizations should be expressing their security policy?
Yeah, I think it has to both be in human and policy. Human review can be can slow down the process ever so slightly, but it is important to make sure that we're verifying the policy as code that we're deploying. And making sure that those misconfigurations aren't happening and hopefully stopping within the development processes, and getting to production with a known good state from that perspective. So making sure that the silos are broke down, because those are the number one impediment of good security and also impeding the application velocity that is happening from there as well.
And you had mentioned this imbalance between security and developers. There seems to be this constant tension between security and software production. Everything's kind of measured in innovation terms, not necessarily in security. But how do you kind of reduce the drag maybe that security is perceived to add to the process while still being secure?
Yeah, I think that goes back also to having a platform with consistent data across all phases of the application lifecycle. And when you have that, it's also providing data into the tools that the developers are most accustomed to using. So, for example, providing the information on the vulnerability analysis of a container image within the CI/CD pipelines when they go to that build process, or providing that feedback to an IAC template that they be or that a developer might be using to deploy an infrastructure to a public cloud environment. And usually developing an IAC template is in an IDE tool, like VS Code, et cetera, and providing that capability within that tool so that they can very easily make those changes that security would like them to have, so that security isn't as much as a barrier as it sometimes can be.
Okay. David, any final thoughts on just DoD's approach to cybersecurity in the cloud going forward?
Yeah, I think I think one thing that comes to mind when interacting with DoD customers is not all workloads have to be in classified and IL type environments, right? I think the majority of customers that I talk to within the DoD do have development in lower IL workloads. And so, even if you do have a requirement to, have a certain impact level for your applications when they go into production, I think you can still benefit from security tools, whether it's Palo Alto's or elsewhere within some of those development cycles. And I think it can hopefully make some of the DoD agencies a little bit more secure.
Interesting. All right. Well, again, thank you for your time. Again, I'd like to thank today's guest, David Kubicki, the Senior Solutions Architect Manager for Palo Alto Networks. Thanks for being here.
Thank you.
I'm Justin Doubleday, and you're watching Federal News Network. Now let me send you back to the studio for more on the DoD Cloud Exchange.